Welcome to the Earth Science Classroom. We're on the Earth's interior looking at the lithosphere, which is the sphere of rock. Lithos is rock and sphere is area or region. So rock area or rock space. So what we're looking at really is the lithosphere really is this. It is the entire part of the top. It includes the crust. So we can include the crust and the differences between ocean, which will be right here, the ocean there, and our continental. Now, we discussed in a previous video the composition, density, and differences and similarities between these two crustal subdivisions. And what separates them is the MOHO, which is this black line right here, which signifies a diffraction, a change in velocity of those seismic waves that were recorded coming out of an earthquake and shown to increase in velocity once it goes to a certain depth around 100, between 5 to 7 kilometers under the ocean and an average of 35 kilometers under the continent. That can change based on location, especially under the continents. That can change the altitude and elevation of the surface formations and topography, and thus isostasy would change the lower part, the MOHO. So you have this distinct change in velocity, which would separate the layers and have the crust different to that of the lithosphere in terms of the physical layering, as opposed to the chemical. Now, the chemical also has the crust separate from the mantle. Now, lithosphere is part of the mantle in terms of chemically, and physically, it's part of the upper mantle. So think of chemical as the more straightforward 3 layers of the Earth: crust, mantle, core, and the physical being the more detailed 6 layers of the interior, looking at different characteristics than just the composition, which is chemical. So in terms of composition, you have mostly pyrrhotite, which is a ultramafic igneous rock made from magma, and it is magnesium, and it is lots of iron, okay? And you have a very dense rock. Let's fix that quickly. A very dense rock, and the average density is 3.3 grams per centimeter cubed. Now, that would increase from the MOHO down to an average of 100 kilometers, which is the deepest kind of boundary where, again, the seismic waves would change. Now, just below the lithosphere, in technically the asthenosphere, we do have an area called the LVC, or low velocity zone, where you do see a distinct decrease in velocity of those seismic waves at a depth of between 150 kilometers down to about 250 kilometers. And that's where they assume a lot of the magma is derived or generated or produced. So the lithosphere, think of it as obviously the skin, the top layer of the Earth, still 70 miles on average thick, includes the crust. It is generally pyrrhotite, going to have some basaltic, some granite at the top part. Obviously, that's going to separate into the crust of continent and ocean. But you have a lot higher density, which is going to change the seismic waves and make them increase from the average of 6 kilometers per second over the MOHO, where there's a change, and it goes to 8 kilometers per second. And then down to, again, 100 kilometers, where you'll see another change in velocity, which is called a discontinuity. Okay, so a change in velocity. So it's all about those seismic waves. That's the way we kind of assume that the rocks, the interiors design, shape, makeup, because obviously we can't go there. The deepest we've gone is about 7 miles with the Kola borehole in Russia, which is an absolutely awesome feat of engineering. It took years and years and years, but still, we didn't get too far down into the crust, nowhere near to really reach the lithosphere or even the asthenosphere. So, in terms of lithosphere, we're going to take from this the key points is the more general, uniformed composition, periodicite, the density, and the depth. All right. So hopefully this works. You can refer back to the different crust video and video on the asthenosphere, which is a lot more structured in terms of its layer and what it does with the waves and its temperature and pressure profile. And I hope this helps, guys. And join me for the Earth Science classroom video.